This assessment asks us to predict the mechanism for the acetal formation reaction. The isopropyl alcohol reagent is a weak nucleophile. It cannot directly attack the carbonyl. It will need to wait around for a carbocation to form. So the first thing that we will do is we'll use the isopropanol reagent to deprotonate sulfuric acid. We'll protonate the isopropanol reagent. We can then transfer this proton to the oxygen of the carbonyl. And that will form a protonated carbonyl that is now a better electrophile that even a weak neutral nucleophile like isopropanol can attack. The isopropanol then will use a lone pair of electrons to attack the carbonyl. We don't have any arrows showing the loss of the hydrogen from isopropanol, so that oxygen will still have its hydrogen, which means that oxygen has a positive charge. We just added that isopropanol group to that carbon because we're trying to form the acetal, so we'd like this group to stay, but right now it's the best leaving group. So we need to make this group not the best leaving group and make something else the best leaving group. To do that, we'll take another equivalent of isopropanol and use that to deprotonate this acidic proton. This protonated isopropanol intermediate can then be used to protonate the other oxygen in the intermediate. That has now turned the OH2 positive group into the best leaving group. So we will have it leave. We can use a lone pair of electrons on the isopropanol group, isopropoxy group, to reform a carbonyl, kicking out our good leaving group. We can then add another equivalent of isopropanol to the carbonyl. Again, we don't have any arrows showing the loss of this hydrogen, so this oxygen still has its hydrogen attached and therefore a positive charge. And in a final proton transfer step, we can neutralize this oxygen to form our final product of the acetal. This is the mechanism for this acetal formation reaction.